In this video, we're going to explore the concept of implicit conversions with overloaded binary operators. The first thing we're going to bring to your attention is that when a binary operator, like the addition operator, subtraction operator, or really any operator that takes two operands, is implemented as a member function, the left operand is never implicitly converted. So what do we mean by that? Suppose we have a class number that we have used previously. We have an object of that here, and we want to print stuff out on the console. We do something like this. We print number 1. This is going to work. We try and print number 1 plus 5. We do something like this. I hope you feel that this is something you might want to do. So we do this and it works. But if you try and do something like this, you say 5 plus number 1, and you do this in hope that the compiler is going to implicitly convert the 5 here to a number using the constructor of the number class. And this is not going to work because the left operand is never implicitly converted. So you're going to get a compiler error here. And the big reason is this thing is implemented as a member function. The plus operator is done as a member function of the number class. So the implicit conversion is not going to work because the compiler is going to call this operator on the first operand. And the first operand is just a number. And the compiler doesn't know which class to implicitly convert this to. So this is the problem I want to bring to your attention. But if we do the minus operation here and we say 5 minus number 1, this is going to work because this guy is implemented as a non-member freestanding global function. So this is what I want to bring to your attention. If you desire to use implicit conversion like we are doing on this line here, you have no choice but to do your binary operator as a freestanding global function. And the program is coming from the fact that our plus operator is done as a member function, and implicit conversions are not supported for the left operand because the operator is called on the left operand itself. I hope this makes sense. Now that we know this, we're going to head over to Visual Studio Code and play with this a little more. Okay, so here we are in our working folder. The current project is implicit conversions with overloaded binary operators. We're going to grab the code from the last lecture because we're going to be stealing the number class. So what we're going to do is grab the main CPP file, the number CPP file, the number.h file, and we're going to grab the VS Code folder because that's going to give us the configurations that we can use as a starting point in our program. So we're going to go in our current project and paste in what we have just stolen. And we're going to drag this little guy on top of Visual Studio Code here to have our project open. We can go in the main CPP file and make sure we have what we want. So what we're going to do is take out the functions on top here that we don't need, and we're going to leave in number 1. And what we're going to do is try and print this little guy on the console. So we're going to say stdc out, and we're going to say n1, and we're going to put this out on the console. And why do we have these includes problem? Let's see, IO stream is not available. Let's try and build this. We're going to pass this through GCC. We are including point here and it's not available. So what do? We can take out the point header, and we're going to take out the custom type conversion to point because we don't need that here in this class. We're going to head over to number.cpp. I think we're not going to be using that point class. We're going to go back to main and take out point, and now I think we should be fine. We have number.h here, and we're going to try and build again. Okay, now the build is good, and we can do our thing. So we can come here and try and run this application. We're going to bring up a terminal, and we're going to clear and run rooster. We're going to see that our number is going to be printed. But what if we want to print something like this? N1 plus maybe 2. Suppose you do something like this in your program, and we're going to say n1 plus 2, and you're going to see that the Visual Studio Code IDE or editor is not going to give us any squiggly lines, so this gives us some hope that this is going to compile, and we're going to pass this through GCC, and you're going to see that this is going to work. So what is going on here? Well, the compiler is going to look at the second operand here, and it's going to implicitly convert this to a number and then use the plus operator that we have in our program here. And we have done the plus operator as a non-member. This is something you should understand by now. So the plus operator is done as a non-member, and the second operand here is going to be converted implicitly to a number, and then the plus operator is going to be used to do the addition. And why is this working? Because our number class here is not explicit. If we wanted to prevent this constructor here to be used in implicit conversion, for example, we could mark it as explicit. This could cause for the code here not to work, because now the compiler can't use our constructor to convert this number to a number class object that we can use in this addition here. And if we try to compile, the compiler is going to be confused by this little guy, and we're going to get a message here saying no known conversion for argument 2 from int to a const number object. So this is not going to work, and implicit conversions are desirable here. That's why we're going to take out the explicit keyword and build to get this to work. So this is going to do just fine. The build is going to be good, as you see here. But the problem is going to come if you change the implementation of the plus operator, for example, to a member function. And we're going to take this out now. So let's go in our implementation file and change this to be a member function. What we're going to do is come in our class, go in the public scope, and we're going to put in a plus operator. The plus operator is going to return a number, and it's going to be operator plus, and the second operand is going to be a const number object passed by reference, and we're going to return a number, and we're going to take the wrapped int from the current object, and we're going to add the wrapped number from the right operand. So we're going to say right and say m wrapped int, and this is going to work. So let's make sure we have one pair of parentheses in here. And also we should make this guy const, because it's not going to be modifying our object here. And this is going to still work because implicit conversions are supported for the second operand here. So if we build, the build is going to be good, and we're going to get the sum printed out. So we should get 24 printed out on the console for the second line here. We're going to run rooster, and we're going to see 24. This is what we expect. So what if we try and did something like 2 plus n1? I want you to see these things step by step, because they can really be confusing to new people. So we're going to say 2 plus n1. And remember, our plus operator is done as a member function now. So we're going to say stdendl to put our new line character here. And notice that we have a squiggly line. And this is a hint that this is not going to work. So we're going to have a problem in Visual Studio Code in the problems tab saying no operator plus matches these operands, int and number. And we did this in hope that the compiler would insert an implicit conversion using the constructor that we have that takes an int. And the compiler is not taking that because implicit conversions are not supported for the first operand when your operator is done as a member, because the operator is really called on the first operand, and the first operand is not a number type. So the compiler doesn't really know that it could transform this to a number, because if you think about it, there could be thousands of classes that could support this kind of implicit conversion, and the compiler doesn't really know which one it's going to choose. So the C++ standard disallows implicit conversions when your operator is done as a member function and the first operand is the one you want to do implicit conversions on. So this is not going to work. But notice that if we do this, for example, for the minus operator, which is done as a non-member freestanding global function, this is going to work. So we're going to say minus, and we're going to say 2 minus, or let's say 42. To get this to be a positive number, we're going to say minus and n1, and we're going to say 42 minus n1 here. And you're going to see that this is going to work. This is not going to give us any squiggly line because the minus function is done as a non-member. So the message here is, if you want to support implicit conversions for your binary operators, you should do them as non-member freestanding global functions, as we are doing the minus, multiplication, division, and modulus operator here. This is going to give you implicit conversions, but if you do that as a member function, implicit conversions are not going to kick in for the first operand in lines of code like we have on 11 here. This is not going to work. So if we want the line here to work and use implicit conversions for the first operand, we have no choice but to do that as a member function, and we're going to do that here. So let's take this out, or I'm not going to take that out. I'm going to comment this out and leave this in as a reference. I like to do this for my code in courses, and I am going to say implicit conversions won't work for the first operand, and you should know this here. So we're going to uncomment the lines we had before that did this as a non-member freestanding global function. We're going to head over to the CPP file and uncomment this. And now implicit conversions are going to kick in and work for line 11 here, because now the plus operator is done as a non-member freestanding global function. So we're going to build again with GCC. The build is going to be good, and if we clear and run Rooster, we're going to get what we expect. 2 plus n1 is going to be 24, and this is really cool. This is really all I had to share in this lecture. I hope you found it interesting. We are going to stop here in this lecture. In the next one, we're going to see how we can overload unary operators like the plus plus operator, the minus minus operator, and we're going to see that we can do these guys as prefix or postfix operators, and that's going to be really cool. So go ahead and finish up here and meet me there.